The sine of angle A is defined as the opposite leg over the hypotenuse, so that is A over C. The cosine, and on your calculator, it will say cosine or COS, not cos, it's cosine of angle A. Instead of it being the opposite leg, it is the adjacent leg. This would be the adjacent leg. So that would be B over C. And last but not least is tangent. We call it tan A on the calculator. If you look at your calculator, you'll see buttons that say COS, SIN, TAN. That's what those are. This is the tangent of angle A, and it is the opposite leg over the adjacent leg. And in this case, this is opposite. Remember, this is going to be opposite. This is going to be adjacent. So it's going to be A over B. Okay? Now, all of that seems like, well, okay, whatever, Mr. Hunt, who cares? So you're going to see why that's useful in the coming slides. I'm going to go ahead and, oh, actually, let me give you one more thing. You may want to write this down as kind of a cheat sheet, if you will. So, ka, hoa. That's how I used to say it when I was in high school. That's how I would say it. I would say, so, ka, hoa. And you might be like, what the heck does that mean? I'll show you what it means. Guess what S stands for? Sine. And what is sine? It is opposite over hypotenuse. That's why it's OH. So. Ka. Can you guess why there's a C right there? Cosine. Which is adjacent over hypotenuse. Adjacent over hypotenuse. Toa. Guess why there's a T there? Tangent, which is opposite over adjacent. So it's OA. So, ka, toa. I'm mentioning that to you because it has always helped me remember these ratios. It's called a mnemonic device. Okay. So let's go ahead and we're going to do example 1 here together. Or actually, I'm going to do part A. I'm going to let you do part B. So let's go ahead and start part A. It says, find the sine, cosine, and tangent ratios for angle C. So we're talking about this angle right here. There's angle C. And I'm going to actually, just to model what I was just, I'm going to write so, ka, hoa. Just to help me make sure I don't screw this up. So I want to find the sine of angle C. Okay? And typically, guys, I'm just going to actually tell you right now, I don't mind if you write it this way or if you just say it this way. The sine of C. If you want to put the angle symbol in there, you can, or just sine C, that's fine. Now, what does sine mean? Sine means opposite over hypotenuse. So that means I got to go opposite over hypotenuse. So that's going to be 30 over 34. Now, guys, we need to reduce this fraction, and I think 2 goes into both of those, so I think it's going to be 15 over 17. That's the answer for that one. That is the sine ratio for angle C. Opposite over hypotenuse. Okay, let's do another one. Let's go ahead and look at the cosine of C. What will the cosine of C be? Well, now I'm going to look here. Ka. That's cosine, and A means adjacent, and H means hypotenuse. So that means I need to go this over this, because this is the adjacent side. This is the hypotenuse. So that means this one's going to be 16 over 34. Well, let's see here. Can I simplify that one? Well, does 2 go into 16 and 34? I think it does. So that's going to give us 8 over 17. And I'm going to erase some of this other stuff that I've got written on here. Last but not least, tangent of C. So I'll call it tangent C. Toa. So now we're on that last piece. That is opposite over adjacent. So that means this is opposite, this is adjacent, so that means it's going to be 30 over 16. And again, that can be reduced. I think 2 goes into both of those, so that'd be 15 over 8. So I have just found all 3 trig ratios for the angle C. Now I'm going to ask you, would you please find the same ratios, but now for angle A? So just very quickly, please reduce like I did. Find the ratios for sine, cosine, and tangent of angle A. Angle A is up here, so these are going to be different answers. Okay, so let's go ahead and look at this. Now, if we're talking about angle A, I'm going to have to get rid of all this stuff I've written on this one already, because if I'm up here at angle A, if this is the angle I'm trying to focus on, this is still and always going to be the hypotenuse, but now this is the opposite leg, and now this is the adjacent leg. You're looking at angle A, you see that 30? That's right next to the angle, so that's the adjacent side. And that 16 is now the opposite side. So the sine of angle A is going to be 16 over 34, which is 8 over 17. The cosine of A, that's going to be, remember, we're doing now cos, so that's got to be adjacent over hypotenuse, so that's going to be 30 over 34. That's going to be 15 over 17. And the tangent of A, tangent, remember, is opposite over adjacent, is going to be 16 over 34, and that's going to give us 8 over 15. Those are the answers for that particular angle A. Does anybody have any questions on that? Does anybody notice anything interesting between the answers for part A and part B? No. Yeah. Notice that the cosine of angle A is equal to the sine of angle C. The sine of angle A was equal to the cosine of angle C. But notice that the tangent of A is completely different than the tangent of C. All right, let's go ahead and move on if no one has any questions. Now here's where we're going to use our calculator. Please, please, please do not pretend like you're doing this Do this now. Make sure you know how to use your calculator. This is very important. And once again, I will mention that when you turn your calculator on, down at the bottom of the screen, it should say DEG. Okay, so here we go. Here's how you use your calculator to do this problem. Problem A says use your calculator to find the sine of 57. You are literally just going to hit sine 57 and hit enter. The answer is 0.83867. That's the answer. That's all there is to this. If you did not get that answer when you typed in sine of 57, it's probably because you are not in degrees. Please make sure you know how to do this. In fact, I bet you can do the next one all by yourself. The cosine of 122. Well, the cosine of 122 is negative 0.52991926. Now you might think, Mr. Allen, how is that even possible? How is that possible to have a negative there? I'll just tell you honestly, in this class we won't use the negative part, but if you take pre-calculus in the future, you will need to know the negative. It has to do with the fact that that particular angle would be in a different quadrant on the quadrant plane, but let's not worry too much about that. Now let's go ahead and figure out what this last one is. To find the tangent of 28.61 degrees, you're just going to hit tan, 28.61, hit enter, and you get an answer of 0.545444136. Does anybody have any questions on how to use their calculator to find sine, cosine, or tangent? Okay. Would you guys agree that that's pretty easy? You just used it. And by the way, you cannot calculate that by mental math. I am not asking you to do that mental math. I don't even know how to do that with mental math. You have to use a calculator to get these answers. Yeah.
It's all the same on all calculators.
If you're in degrees, yep. Make sure you know how to use your calculator. Okay. So guys, we will have a test coming up here the week before spring break. Not next week, but the week after that. And I'm telling you right now, I'm already predicting, there are students that will not have known how to use their calculator. They're going to be in the wrong setting, and they're going to get wrong answers, and they're going to be so confused. It's not hard. You just got to make sure you're in degrees. In fact, let me make a note on this. Maybe you should make a note in your notes. Make sure your calculator is in degrees. Make sure your calculator is in degrees. We will only do degrees in this class. If you take pre-calculus in the future, you'll do radians, but don't worry about what radians are. All right, example number 3. Now, Mr. Allen, this all seems great, but why in the world would I need to know this? Well, now you're going to see why. In fact, let's do A first. Suppose I asked you to find the value of x. What is x? You might look at that and you might think, well, Mr. Allen, that's a right triangle. I'll just do the Pythagorean theorem. What's the problem with that? By the way, those of you guys that are virtual, I would appreciate it if you would answer the poll question that I just put out. Well, the reason you can't do the Pythagorean theorem here is how many sides do you know? You only know one. To do the Pythagorean theorem, how many sides do you need? You need 2. So we're going to have to use those trig ratios. Now, the most important question right now is, should I be using sine, should I be using cosine, or should I be using tangent on this problem? Well, to answer that question, Here's the angle we have. What would we call this side right here? We call it, what is that? X. Let's start with this one. What's this side over here called? The 6. Well, that's called the hypotenuse, right? Remember, the hypotenuse is always opposite the right angle. Now, if the angle here is 73, this side right here is what we would call the adjacent sides. So which of our ratios has something to do with the adjacent side and the hypotenuse? Well, it's not sine.
Oh, it's not.
It's not sine because sine says opposite over hypotenuse, so it can't be sine. What about cosine? That one says adjacent over hypotenuse. So that's what I'm going to use. So we're going to use cosine on this one. We're going to say that the cosine of 73 is equal to x over 6. This is the hardest step and the most important step. You cannot use sine on this problem, and you cannot use tangent on this problem. You have to recognize that in this particular problem, we are given the angle 73, that would be this angle right here, and we see that x is the adjacent side, and 6 is the hypotenuse, so I have to do cosine because cosine is adjacent over hypotenuse. All of that gives me the following equation. So now let's just go ahead and solve this equation. How are we going to solve that equation? Well, it's actually very simple. Let's just go ahead and find the cosine of 73, which is very easy to do with our calculator. I'm going to just type cosine 73 and hit enter. And it gives me 0.292371705 equals, and I've still got that x over 6 over there. How do I get rid of that 6 on the bottom there? Well, that's division, right? What's the inverse of division? Oh, it's just times. So all you got to do is take that number there and just hit times 6. The answer is 1.754. That's your answer to the problem. 1.754. I'm just going to go ahead and leave it like, oh wait, I'm sorry, it says round to the nearest hundredth. I need to be careful. That is rounded to the nearest what? Well, the first place, that's 7 is tenths, then 5 is hundredths. Oh, I guess I already did it. That's thousandths, so I got to do one more. So the correct answer here should be 1.75. That is rounded to the nearest hundredth. This was to the nearest thousand. That's not what the directions say. Thousand. Okay. So let me go through again what I did here. Let me erase some of this, all these markings up here. This is kind of a hot mess. So let me get rid of that, let me get rid of that, let me get rid of that, and let me get rid of this guy. So here's a triangle. I'm trying to figure out what x is. I don't know what x is. I do know, though, that that side I'm trying to find is the adjacent side, and I know the hypotenuse, and I know the angle. That led me to using cosine, not sine and not tangent, because those two guys don't involve the adjacent side and the hypotenuse. Cosine did. So then I said the cosine of 75 equals x over 6. The cosine of 75 is x over 6. And then I just solved the simple one-step equation. Would you do me a favor on part B? Would you just write down which ratio you think you need to use for that one? For part B, you don't need to solve it. Are we going to use sine? Are we going to use cosine? Or are we going to use tangent? Would you please try to figure out which one you think we're going to use on that? If you're not sure, go back a couple of slides and look at those ratios. Would someone in the virtual part of the class please send a message in the chat about which ratio you think we should use? Sine, cosine, or tangent? Okay, I'm not getting any response from the virtualists. Does anybody here in class want to tell me which of those three you think we should use? Sine, cosine, or tangent? I think you're absolutely right. That is exactly right. The correct answer is tangent. The reason is, let's go ahead and label this. Here's our angle. This would be the opposite side, and this would be the adjacent side. Remember, this is the hypotenuse, and we don't know anything about it. And since we don't know anything about the hypotenuse, we don't know what that is, that means sine and cosine cannot be part of the answer, because those both involve hypotenuse. In other words, here's how we write it. The tangent of the angle, so that's tangent of 37, a very ugly 7, sorry about that. The tangent of 37 is equal to, now you got to go opposite, remember it's so, ka, toa, right? We're looking at this one, so we want to do opposite, so that's x, over adjacent, which is 12. This is the equation that we need to solve. Would you do me a favor? Would you go and just solve that equation for me? Round to the nearest hundredth. You're going to do the same type of thing I did down here. Get your answer. I will do the same. So with your calculator, you just need to do the tangent of 37 and then multiply it by 12. You will get an answer of 9.04 to the nearest hundredth. Does anybody have any questions on this example? Okay, so before I move on to the next slide, I want to make a note. Okay, these problems, we found a missing side length. Running out of room. On these two examples, there was a side we were trying to figure out. We were trying to figure out x, we were trying to figure out x. Those were lengths of sides. Okay? Let's go and look at our next set of examples. How is that different than what we're doing here? Well, here we're trying to find angles. So these are going to be different. Let me do example A. Let's do it in red. So the first thing we want to try to figure out is, are we going to use sine, cosine, or tangent? And let me go ahead and write that ratio up here again, remember? So, ka, toa. That helps me remember it. It might help you remember it. Which one are we going to want to use here? Do we want to use sine, cosine, or tangent? The answer? We're going to use sine again on this one. Let me explain why we're using sine. Here's the angle we're interested in. 11 is opposite that angle, isn't it? And the 27 is the hypotenuse. That kind of doesn't look like hypotenuse. Make that look more like an H. So we're going to use sine. In other words, and guys, if you guys don't mind, I'm just going to go ahead. I do this with my other classes. I hope that doesn't scare you too much. I'm just going to write this, and then I'll tell you what it means. This right here is the Greek letter theta. I can spell letter. The Greek letter theta. We use it a lot. I cannot spell for the life of me. There's not an H there. It's just theta, T-H-E-T-A. I don't know if you guys are familiar with that Greek letter. It's just like X. We just typically use theta when we're talking about angles. So the sine of theta is equal to the opposite, which is 11, over the hypotenuse, which is 27. Okay, now this is a question that you definitely want to make sure you're paying attention to. How am I going to figure this out? What this is saying is that the angle theta, the sine of that angle, gives you this answer. So you're going to have to look, and in fact, let me just write this down. You are going to have to do sine inverse of 11/27. By the way, some books, some calculators will have it written this way. These mean exactly the same thing. Your calculator, if you have one like mine, it'll say, you see the sine button right above it? You see where it says sine to the -1? To get to that, you have to hit second sine. Second sine. And then just type 11 divided by 27, hit enter, and you will get, and this is x, or theta, this is theta. So theta here is 24.042. Let's go ahead and do that one to the thousands. Please, please, please make sure you can get that answer. I wrote it in a couple of different ways. This is probably how most calculators, this is probably how your calculator works right here, is this one. You guys probably have the sine to the -1 on your calculator. However, I'm mentioning this arc sine here, this is also how some other calculators and some other textbooks have it written, and I want you to be familiar. They are both the same thing. It basically just means that it is undoing the sine function. Are you guys okay in here on this? Did you guys get that 24.042? Okay. Did you get that? Your calculator is probably a little bit different. No, get clear. You have to, where's your second function feature? Yes, all these calculations are really good. So, you can try that button, and then oh, shit, you can shift. So, there we go. Now do the 11. Are you good? Are you good, Tomas? Yeah, you got a harder one, don't you? Oh shit, you gotta do shift, hit that, and then where's your sign button? Hit sign. And now do 11 divided by 27. Divided by 27. Okay, get clear. Let's try this then. Do 11 divided by 27. Hit enter. Now hit shift, sign, enter. So you've got a Casio, so you actually have to put the 11 divided by 27 in first. Okay? Or if you want, Tomas, you can use a calculator back here. Are you good? Awesome. Are you okay? Awesome. Are you good?
Yeah.
Okay.
Yeah.
Okay, guys, sorry, I took a minute here. I want to make sure everyone, if you're not here today, you're kind of on your own. I expect you to be able to figure that out. I know how to use this calculator. I know how to use graphing calculators, but there's a whole lot. There's Casios, there's Sharps, there's all kinds of calculators. All right, let's go ahead and look at B. All right, so to do B, are we going to use sine, cosine, or tangent? Here's the angle. Which of the three do you think we're going to use there? Yes. Tangent, absolutely. This one we're going to use tangent because 14 is opposite the angle and 29 is adjacent. So that means we're going to do tangent. These other two will not work. So that means we're going to do the tangent. And again, I'm going to call that theta if you guys don't mind. The tangent of theta is equal to 14 over 29. So theta is going to be equal to, and I'm just going to write it the way your calculator would have it. Most of you at least. So that's what you need to plug into your calculator. Tan to the negative 1, that's the inverse of tangent, divided 14 over 29. I'll do the same. Second. And I've got theta just 25.769. And I guess I should maybe mention this. This is degrees. These are degrees. Here on this slide, we were finding angles. Here we were finding angles. On the last slide, we were finding side lengths. Here we're finding angle measures. Okay. So far, so good. We're almost done. We got one more example, and then we'll do some practice, and then we'll call it a day. All right. Please don't forget you have homework due tonight. All right. Last example. Wouldn't be a geometry class without trying to do something that's an application, a real life problem. So let's see what we've got here. It says find the height of a building if the angle of elevation, that's this angle right here. Notice that even in this diagram, which is one I stole offline, this angle here, they marked it as theta. Find the height of the building if the angle of elevation is 32.5 degrees and the distance away from the base of the building, that's this distance right here, is 842 feet. So what I'm saying is we've got some person down here, they're looking up to the top of the building. They somehow, and this is, I know it's a little ridiculous, but let's say they have some way to figure out the measure of the angle, and they know that this, in fact, let's draw another picture here just to kind of emphasize this. We'll do it in black. So we've got our right triangle here. We know that this is 842 feet, and we know that this angle right here, which I'll call theta, is 32.5 degrees. And we want to know what's that height. Which ratio do you think we need to use on this one? Now notice now I want you to just think about it. Don't say it, don't write it yet. Look at what I just drew. Which ratio is it? Is it going to be sine? Is it going to be cosine? Or is it going to be tangent? Would someone in the chat let me know which one I want to use on this one? Do I want to use sine, cosine, or tangent? Actually, you know what? I got one more poll question here for you guys that are remote. So let's hit that. What do you think, Alex? Okay, cosine. All right, so let's see here. Remember, we're talking about SOH, CA, TOA, right? So cosine means we want to know adjacent and hypotenuse. Well, we know adjacent, that's for sure. Do we know the hypotenuse? We do not. Do we want to know the hypotenuse? We do not. So cosine is not going to be what we want to use here.
Are we using tan?
We are going to use the tangent. That is correct. We are going to use tangent. We're not going to use sine. We're not, because the hypotenuse here, there's nothing in this problem. Nothing in this problem tells us that we want this length or know that length. We know this length, which is the adjacent, and we want to find the opposite side length. That's what we want to find. So that means we're going to use tangent again. So we're going to say that the tangent of 32.5 is equal to h over 842. Would you please go ahead and calculate that answer? And there's your answer. 536.413 feet. So what I'm telling you is this, and by the way, this is why ancient mathematicians actually developed mathematics, one of the reasons, I guess. How do you find the height of something that you can't measure? You can't just put a tape measure up to this, but maybe you could measure this distance here, which turned out to be 842 feet. And maybe you have a device, in fact, maybe I'll just leave that as a question. What is a device called that we could use to measure angles? You can measure this angle. And based on those two numbers, you can actually get the answer for the height of that particular building. This is called indirect measure, and it's very handy. In fact, the ancient Greeks, 2,000 years ago, basically approximated the distance from the Earth to the moon. And they did not have calculators. They did not have computers. They just had their intellect, and that's how they did it, and actually did a very good job. So guys, we are right at the 1 hour mark. What I'm going to do though right now, I am not going to give you guys an exit slip today. I am going to give you some practice problems, and I'm going to leave this up to you if you feel like you need to practice this a little bit, which you probably do, no offense. These things are not really that difficult, but if you don't practice them, they kind of go by the wayside, and you end up finding out you don't know what you're doing. I'm going to stop recording at this point. I just sent a link for those of you that are online, and there are